good morning, good afternoon, good evening. Whatever time you are watching me, I wish you happy Christmas. And I also want us to stay updated in this channel by following it, subscribing to it, liking it, and sharing it to your loved ones. Today, we are going to be looking at INDICIAL equation. But before we go into looking at INDICIAL equation, in our last lesson, there was a question that was asked by one of my good students in my comment. So I want us to look at it very briefly before we go into INDICIAL equation. It will be of benefit to some of you watching me now. So, and this is the question he asks. He says, simplify 0.027 raised to power 1 all over 3. When you have a problem like this is indices. When you have a problem like this, that it is in decimal and raised to a negative power here, change this decimal to fraction. And to change this decimal to fraction, you consider the number of digits after the decimal point. So because 00 means nothing, you now look, the number of digits after the decimal point is 1, 2, 3. So you are going to look for the tenth, the hundred, the thousand, the million of 27. Not 0.27. 0.27 is something as saying 27. So you are going to convert this decimal to fraction. And how do you do it? Become 27 all over. The number of digits after the decimal point is what will now be considered as the denominator here now. So we have 1, 2, 3. It is 3 digits, and 3 digits make 1,000. If we have 2 digits, it will be 100. If we have 1 digit after the decimal point, is 10. If we have 6 digits after the decimal point, is 1 million. So it will now become this, raised to power this. So we have converted the decimal to fraction. So now, this is now to remove this negative index, we need to invert the base here now by taking the denominator up and bringing the numerator down. That is to say 1,000 divided by 27. So it's 1 all over 3. Now we have removed the minus. So this raised to power 1 all over 3 is guiding the numerator and the denominator. And this is the cube root of the numerator and the denominator. And we are told that to get the cube root here is determined by the denominator. They get the root of a number is being determined by the denominator. So the denominator here is 3. So it becomes cube root, which is this, over 27. So now, the cube root of 1,000 all over 27. So you look for a number that when you multiply number 3 times by itself will give us 1,000. And also a number that when you multiply by itself 3 times will give us 27. So if you look at it, you see that 10 can go. Multiply 10 3 times. 10 times 10 times 10 will give us 1,000. So 10 is the cube root of 1,000. So another number that will multiply by itself 3 times to give us 27 is 3. So times 3 times 3 times 3 will give us 27. So is the cube root of 27. So now you now see that this number are not divisible. The numerator and the denominator, they are not divisible. And there is no number that can go into 10 and also go into the denominator. Here would have served as the answer, but in fraction, in mathematics, when you have a fraction where the numerator is bigger than the denominator, you convert it to mixed number or mixed fraction. So you look for a number that when you multiply that number, how do you convert to mixed fraction? You look for a number that when you multiply that number by the denominator, which is 3 here, will give you a result that is closer to 10. And whatever is to be added to the result to make it 10 will be smaller than the denominator, which is 3. So let us look at 3. Now 3 times 3 is 9. You see that 9 is closer to 10. And what is to be added to 9 to make it 10 is 1. And that 1 is smaller than the denominator is 3. So become that 1 we have to add is 1 all over 3. So here serve as the answer. So you can see how simple this problem is. For you who have just asked that question, see how simple it is. And for those of you watching, it's so simple. So we are going to look at now the INDICIAL equation. So what is INDICIAL equation? INDICIAL equation is an equation is indices in an equation form. Indices in an equation form is what we call INDICIAL equation. indicial equation. Indicial equation is an indices in an equation form. So now, for example, we have 2 raised to power x is equals to 32. So this, the x here is the power, the 2 here is the base. It's expressed in a number 32. So now, what you have such a problem means you are expected to look for x. So you try to see how you can equate, you can make the base be the same. And you now, since here is 2 raised to power x is equals to, try to see how many times can also try 2. How many times can 2 multiply itself? Since here is 2, try 2 to see whether it can multiply itself number of times to give you 32. We now see that when you multiply 2 5 times by itself, will give you 32. So we can now see that the bases are the same. So what you need to do is to equate the powers. You equate the powers. And equating the powers here, since the bases are the same, become x is equals to 5. You can see that this is the answer of this. This is an indicial equation. So we are going to look at another indicial equation again. As you have seen here in the board, it's very simple. So we are going to look at the next indicial equation. Just stay updated and watch. Ask question, go to the comment section and drop your question. So we are going to look at the next indicial equation. Here to solve 8x is equals to 0.25. This is another indicial equation on the board. But what you need to do when you have a decimal like this index and the base is expressed to 0.27. So you now convert this 0.27 to fraction. This in decimal form, convert it to fraction. Make sure that when you have a problem that's in decimal form, always convert it to fraction. And like we were told in the first example, when you have a problem like this in decimal, you convert it to fraction, and it will now be 25 raised to power all over 100. So why is it 100? Is the number of digits after the decimal point. The denominator here, the 100 of this will be determined by the number of digits after the decimal point, and the number of digits after the decimal point is 1, 2. That is why it is 100. If you have 1 digit after the decimal point, it will be 10. If you have 3 digits, it will be 1000. So take note, it's very, very important. So in this case now, you are going to have 8 raised to power x is equals to. Now you can see this now. This is 25 can goes into 100. How many times? 4 times. So you're having 1 all over 4. So now having this, you can change this to indices now. So it now become 4 raised to power minus 1. Remember that if you have number like this, 4 raised to power minus 1, is the same thing as saying, to remove this man, become reciprocal of 4 raised to power this 1. And it's the same thing as saying 1 all over 4. Anything raised to power 1 is 4. So take note of that. So in this case, you are going to be having, now you now try to see how you can make the basis be the same. That is what is very important when you have an indicial equation. Try everything to see how you can make the basis be the same. And how do you make the basis be the same? You look for a number that when you multiply that number by itself, number of times will give us this base 8. And also that same number, if you multiply it by the number of times by itself, will give us the base 4. So if we try to 2 raised to power 3 will give us 8. You multiply 2 times 2 times 2 will give us 8. Also 2 here, you multiply 2 by itself 2 times will give us 4. So you can see what we have done here. And this is the same thing as saying, 2, same thing as saying 3 times x is equals to 2 times minus 1. So 3 times x is 3x is equals to 2 times minus 1 is minus 2. So now you can now see that the bases are the same. You now equate the powers. Equate the powers. The powers. When you equate the powers, become 3x is equals to minus 2. So in this case now, you are looking for x. And the coefficient of x here is 3. So what you need to do is that you divide both sides by 3. Divide both sides by 3. So when you divide both sides by 3, you are going to have 3x divided by 3 is equals to 2 minus 2 divided by 3. So this 3 will take this. You are left with x. X is equals to minus 2 divided by 3. You can see that. See how simple this problem is. So that is what you are expected to note. And this serves as the answer. You can see that the numerator is smaller than the denominator. So this is what is so important. So take note how to solve INDICIAL problem. So we are going to draw the curtain here. In our next class, we are going to be looking at further problems in INDICIAL equation. So stay updated, subscribe to this channel, like it, follow it for more updates, share it to your loved ones. For those of you who are facing exams, this is the time you can now be taught mathematics in the comfort of your room. Mathematics is in the comfort of your room. At your comfort, you can just go through mathematics with ease. So while you are there, you take your notebook, your pen, jot out, solve problems as many as you can. But in our next class, I'll give you some problems to try. So, but for today, we are going to draw the curtain here. So stay updated as you subscribe to this channel. You are welcome. Happy Christmas again. So I wish you happy Christmas by giving you this lesson. Thank you very much.